Oh, you may think you know tech news. Psh, I'll show you tech news. If you just keep watching the episode. You're supposed to go to the intro.
Play MOBAs in silence with 0 decibel fan technology in the Strix GTX 960 by ASUS.
Microsoft has made a number of announcements concerning Windows 10, and all of them are pretty good. First off, the company has pegged summer 2015 as the launch window for the new OS, which will be made available in 170 countries and 111 languages. Windows 10 will come with a new biometric login system called Windows Hello, which will use fingerprint, face, or iris scans to unlock your device, as well as to authenticate online accounts and purchases. You'll need compatible hardware to enable the feature, such as a fingerprint reader or Intel's RealSense cameras in your device. Normal cameras won't do the trick. Oh, great! Thanks, Obama! Microsoft is also going to make Windows 10 free for pirates. Yep, even if you have an illegitimate copy of Windows 7 or 8, you'll be able to upgrade to Windows 10 for free. Definitely an unusual move for Microsoft, but it makes sense. If you're already offering it for free and people are going to crack it anyways, they might as well be running a legit version, so they're sort of in your ecosystem, at least. How much you want to bet people are still gonna pirate it, though, just for old time's sake. And the news won't stop. It looks like Microsoft also has plans to introduce a Windows 10 ROM for Android phones. As part of the Windows Insider program, the company is letting users in China with a Xiaomi Mi 4 that sounds funny. Xiaomi Mi 4 phone flash their device with Windows 10 just like you might do with a ROM. I think I would do this. The Lumia big giant camera phones are appealing to me, but I don't want to make a leap of faith to Windows Phone. I could just flash Windows to my Android and see if it works. Oh, Microsoft, you are sneaky. Speaking of Android phones, HTC has just announced Uh-Oh protection, which will give 1M9 users a free phone replacement if they crack their screen, get water damage, or even have to switch carriers in the first 12 months. If you don't need to replace it in that time, you get $100 towards a new HTC One in the future. The 1M9 is going to launch on various carriers April 10th. Dang, HTC! Between the Revive headset and this, looks like you're getting your mojo back. You been working out? Quick Bits! Carbon 3D is a new 3D printing system that's apparently 25 to 100 times faster than conventional methods because it uses light and oxygen-sensitive resin to create objects from a primordial ooze, much like orcs in The Lord of the Rings. Sony's PlayStation Vue service launches today in New York, Philadelphia, and Chicago, making broadcast network TV channels available to stream online, and Twitter may sell its tweet data to companies looking to advertise more directly to the tweeters. Links for all of today's stories are in the forum post linked in the description. You can't handle the tech! I can't handle it. This is my job. Do you live in Ontario? You don't have to answer that, I get it, privacy. But if you do, we're having one of our legendary warehouse sales at NCIX in Markham. Next Saturday, March 28th, starting at 10 a.m. Eastern Time, but you'll probably want to get there early because there's crazy deals and free swag. Not necessarily in that order. Click here or the link in the description for more details. All right, that's it for Netlink Daily, guys. Thanks for watching. Don't forget to like and subscribe for more videos like this from NCIX. Now it's time for me to turn a new page in my life. See ya! Turn a page. Jack, the outro.
Oh, right.
Turn the page. You been working out? Oh yeah. Looking good.
Hi, I'm Craig Dunn, a technical writer and developer evangelist at Xamarin. Xamarin lets you build iOS, Android and Mac apps in C# rather than Objective-C or Java. Using familiar tools, you can take advantage of your favorite things about C#, link support, event handling and delegates, and even async support while developing for new mobile and desktop platforms. Today, I'm going to walk through how to get started building cloud-connected iOS and Android apps in C#. To do this, we'll use Windows Azure Mobile Services. Mobile Services is a service within Windows Azure that provides a turnkey backend for mobile apps. With Mobile Services, it's fast and easy to store data in the cloud, authenticate users, and send push notifications. We're going to start by creating a single view Xamarin.iOS app and then connect it to Mobile Services so we can add a scalable backend and take advantage of things like SQL database, Twitter authentication, and push notifications. In this video, we're just going to cover Xamarin.iOS, but most of this will also be helpful for Android. So let's get started. If you've never developed with Xamarin technologies before, Visit xamarin.com to learn about building iOS and Android applications with C# and .NET. Go to xamarin.com/download to install our tools and get started for free. I already have everything set up, so I'm going to skip this step. Today, we're building an iOS app, so you'll need the latest version of Apple's Xcode and the iOS SDK. You can get both items by visiting developer.apple.com and becoming a member of Apple's iOS developer program. I've already done this too, so let's get started. First, I'm going to fire up Xamarin Studio, our free open source IDE. You can also use Visual Studio on Windows for iOS and Android projects. Xamarin Studio shares the same solution and project file formats, so you can easily share code across platforms. I'm creating a new iOS project from the single view application template. The main.cs file is the entry point for the application, and it references the app delegate class where we can implement application lifecycle methods for our app. The application's properties reference the main storyboard file, which is where the user interface layout is defined. Let's edit the storyboard file to see how to build a native user interface with Xamarin Studio and Apple's Xcode. Using Interface Builder, I can easily drag and drop user interface controls from the palette onto the iPhone screen. Here I'm adding some buttons, a label, and a table view control because we're going to ultimately build a to-do list application, and I'd like to list the contents of the database in this control. I'm going to briefly switch back to Xamarin Studio so that it can synchronize with Xcode, which creates a header file for Xcode to use. Back in Interface Builder, choose the Assistant Editor to show the header file associated with this screen. To give a user interface control a name in Xcode, hold down the Control key while dragging from each control onto the header file for our screen. You do not have to write any Objective-C code, just provide a control name when prompted. These names are called outlets in the iOS SDK, and I'm going to create an outlet for all the controls on the screen, so that I can refer to them later in our C# code. We can also add actions, which are analogous to the command pattern in WPF, to handle clicks and other events in the user interface. After control dragging from a control, change the type to an action and give it a name. I'll create actions for both the buttons that we will implement later. Returning to Xamarin Studio, I can see in the designer.cs file that it has automatically generated outlet and action attributed properties and methods for each of the controls on our screen. We can now refer to these controls in code and implement partial methods for the actions. To show how that works, I'm going to implement a simple click event on one of the buttons to update the label. ViewDidLoad is one of the methods called in the application lifecycle for this view. I'm going to use that to add a click handler on the touch-up inside event for our add button. This is very familiar ground for .NET developers. I'm going to simply set the label, title, text property to clicked when I click the button. Now I can simply hit run in Xamarin Studio and it'll fire up the iOS simulator and run our C# code as an iOS application. And when I click the button, the label changes. Building an iOS application using Xamarin and C# is as simple as that. Now let's look at adding Azure to our application. You can try Windows Azure and mobile services for free. You can get up to 10 mobile services and a 20 megabyte SQL database, one service within Azure. When you sign up for the free trial, you're signing up for all of Azure, but today we're just going to take a look at mobile services. Mobile services is a turnkey backend for your mobile app. It's an easy way to store data in the cloud, authenticate users, and send push notifications. You can also add some custom logic through server code and connect to other Windows Azure services. Consume add-ons from the Windows Azure Store, and call any API. In this video we're just going to cover saving data in the cloud, but in later videos we'll cover user authentication and push notifications. I've already signed up and signed in, so I'll head over to the management portal at manage.windowsazure.com. To create a new mobile service, I'm going to hit New, Compute, Mobile Service, Create. The first thing you do is choose a name for your mobile service and either create a new Windows Azure SQL database or connect to an existing one. The name is the first part of the URL and not something your users see, but will need to use it later. You also have the choice of an existing or new SQL database. I'm going to use one I set up earlier. Since I'm in San Francisco, I'm going to deploy this mobile service to the West US data center. To reduce latency, you want to make sure that your mobile service and SQL database are in the same data center. Because I chose to use an existing database, I have to enter the password that I previously set up. Within a few moments, you'll see your new mobile service up and running. Once you see that the status is ready, click on that mobile service name. The first thing you'll see is the Quick Start that gives you the option to either create a new app or to connect an existing app. Even though we're creating an iOS app in this example, since we're writing it in C# using xamarin.ios, we'll find the information more useful under the Windows Store button. Scroll down to connect an existing app and copy and paste the code snippet that provides the authentication information for our service. Then click on the button to create a test table. This will be the data source that we'll use in our application. Now it's time to hook in Azure Mobile Services to save data to the cloud. Using the Xamarin Component Store, you can add a wide variety of functionality to your app. Simply access the menu on the Components folder to open the Component Store. In just a few clicks, I can add the Windows Azure Mobile Services component to the project, which will automatically download the documentation and samples, as well as add the component to our application project and the assembly to the References folder. Now I can reference the Azure Mobile Service classes in my code. Since we're building a to-do list app, we now need to add a class for our to-do items. Add a new C# class just like you would for any .NET project. And to implement it, I'm going to use the class definition right off the Azure component documentation. This class will be persisted directly to the Windows Azure Mobile Services database. Notice that the class name, to-do item, matches the table we created earlier in the Azure portal. We didn't need to specify column names in the portal. They will be automatically created from these object properties. Everything is now in place for us to save data to the cloud using Azure Mobile Services. Firstly, paste in the credentials that we copied from the Azure portal earlier to instantiate a mobile service client instance. Then use the client object to create a reference to a cloud-based to-do item table. Now I'm going to re-implement the add button to create a to-do item and save it via the Azure Mobile Service client. Now I'm going to manually create a new to-do item object instance, set the title property, and then save it to the cloud using the insert async method on the Azure table class. Using Azure Mobile Services to save objects to the cloud is as simple as that. Now that you've seen the basics of wiring up Azure Mobile Services to save an object, I'm going to switch to a finished app, which I've also made a bit prettier, to demonstrate it in action. In addition to saving to-do items with the insert async method, which I just showed, I've also used the update async method when a task is tapped to change its status to complete. And finally, I've wired up the UI table view control to show a list of all incomplete tasks using the table.where method. Notice that it supports a filtering clause to restrict the data download from the Azure SQL database. Now let's run the finished app. Within Xamarin Studio, I hit the play button and the iOS simulator starts straight away. I'll use the add button to create a couple of new tasks, which are then sent back to the Azure Mobile Services database. The data is retrieved back from the database to display the list of incomplete items. Touching an item triggers the update method, which sets the item's completed status to true, which means it's filtered out of the list when it's refreshed. Back in the Azure portal, we can visit the Data tab to explore the to-do items I've entered. You can see that the to-do item table has columns that match our corresponding C# class. During development, you can have your database schema automatically update to match your classes. If you want to flip that off for production, which you should, you'd switch to the Configure tab and turn Dynamic Schema off. Thanks for taking the time to learn a bit about building cloud-connected iOS and Android apps in C# using Xamarin and Windows Azure Mobile Services. We only got started with data today, but you can add authentication via Twitter, Facebook, Google or Microsoft accounts and set up push notifications just as easily. If you have questions, don't hesitate to head to either the Xamarin or Mobile Services forums. Visit xamarin.com or windowsazure.com to find out more.
Developers of today are faced with many challenges. How do you build for many different mobile platforms, integrate with different social networks, and use different services and APIs that are available these days? Windows Azure helps address some of those challenges, particularly with the release and general availability of Azure Mobile Services and Azure Websites, which make it easier for developers to target mobile platforms and also create really powerful backend services that can be used to simplify the development process, save time, and also allow developers to focus on building code rather than working on the plumbing and the infrastructure for their apps. I'm Nick Garkusha in the Windows Azure marketing team, and today I'd like to demo how some of the newest services, Azure Mobile Services and Websites, could be used in a mobile marketing campaign. Here's a very common scenario. A mobile app, in this case we picked an iOS, iPhone app, but could be Windows Phone or Android, And when we go into the app, we're presented with a login screen. And typically this would require wiring up each individual authentication provider. In this case, we want to send in with Facebook. And with Azure Mobile Services, we can just use the identity feature, and that does all the heavy lifting of interacting with Facebook for us. Once we put in our authentication information, Azure handles the rest and gives us back the successful authentication event. Here we go. Now let's say we wanted to submit a photo for this contest. This requires uploading and storing binary data for the media, my photo in this case, and I'm going to just pick one. And the Azure Mobile Services can easily manage setting up the blob storage, providing us back with the HTTP post URL. And when we click submit, we can store the media as well as any other information such as ID, date, time, etc. And we can also read that information back. In this case, the photos that were published, the data tables that are used by Azure Mobile Services makes it a very easy task. Now, we can also run an administrative backend leveraging these same services. Identity, for example, to authenticate with Facebook. We're using a lot of the same code, but now within a web app that's running Azure websites. This communicates with all the same APIs that our mobile client app used as well. But here, in addition to retrieving data, we want to execute some functions on these photos. So for example, we wanted to approve or feature some photos, and we can do so very easily by using the new feature of mobile services called custom APIs, where we can expose as REST my data and other services. So if we want to approve an image or feature an image and then script actions such as push notifications, we can easily do so using Azure Mobile Services. And because there are so many moving parts to this demo, let's look at the project Azure Mobile Services and websites providing all the core services for our app, the plumbing so to speak, and exposing it to our devices on the top left or the web portal on the top right. So in turn, everything in our solution can easily communicate with the identity platform, notification services, or third-party add-ons using Azure Mobile Services. My mobile client SDKs can use Azure Mobile Services REST endpoints to handle things like authentication, store and retrieve data, and Azure helps us manage interaction with blob storage as well. Mobile services also dramatically simplify functions like notification. We can script those very easily as part of our interaction via the custom APIs in our solution, and even have them executed on a schedule if we choose to. And again, we can incorporate third-party add-ons for sending dashboard updates within our web app using Pusher or emails via SendGrid. All of that is accessible via mobile services scripting, making it very, very easy to set up for our solution. And leverage the same exact services, third-party add-ons, custom APIs within our HTML web app as well. And we can do that using REST APIs. Now in this video, we will be dealing with the client mobile development techniques, and specifically using multiple authentication providers, storing and reading data with tables, and also interacting with Azure Storage for Blob. And in part 2, we will be looking specifically at some of the techniques around the web admin backend, leveraging Visual Studio to easily publish .NET ASP MVC apps into Azure websites, and also some of the techniques around building and using custom API for push notifications and using ad hoc reports, as well as some third-party add-ons like SendGrid and Pusher to automate some of the common administrative tasks. So let's get into it. Using Azure Mobile Services for third-party authentication is quite easy. In fact, the work streams are divided into the work on the device and some configuration on the Azure. Let's take a look at the Azure portal. Here we access our mobile services, and from the mobile service we have options of different platforms, iOS, Android, etc., and options to create a new app or connect an existing app, as we can see here. To connect an existing app, all we have to do is include the right libraries for Windows Azure Mobile Services and make the right references in order to connect our project to Azure Mobile Service. And now that we can connect to the app, all we have to do is configure the identity keys. And that we get typically from each authentication provider, Microsoft, Facebook, Twitter, etc. And once we put in the keys, Azure Mobile Services can then take over and do the authentication for us. In order for this to work, in the client itself, we need to configure the project and set up the typical storyboard in this case and wire up all the different screens, and as well as configure the screen that allows us to authenticate against multiple providers. And because we referenced our Azure Mobile Service in our project, all we have to do then is make the call to the Mobile Services client login function. In this case, Mobile Services does all the authentication for us, pops up the screen, validates the user, and then passes back the successful authentication event. So the Mobile Services can do the same thing for every single other device that's being supported right now, and our code, all it has to do is just reference that one specific function. So it doesn't matter if you're using Facebook or Google or Microsoft Windows, that authentication can happen very seamlessly and very easily. On to managing regular data with Azure Mobile Services. Most applications these days require ability to quickly create data, store data, and also secure data for access. Azure Mobile Services does just that with Azure Tables. Let's take a quick look. Back in the Azure portal, we're going under the data feature, which provides access to all the different tables that our application has access to. In this case, photo submissions table is where we store the information for the different photos. That includes things like the title, the Facebook ID of the user that submitted it, as well as other information such as date, feature date, etc. Now, when we go to scripting, we can actually then script actions upon each of the operations, such as insert, or in this case, let's take a look at the read operation. In this case, we wanted to get only the top 20 rows or top 20 submissions and order them by submission date. This is the function that is executed in Azure, but could be very easily accessed from the client SDK. Let's take a look at how. So now we go into the module for submitting photos, the Azure Mobile Services framework, and specify and initiate the table, the Azure table that we want to access. In the next function, all we have to do is then specify the table name, in this case, photo submission, and to get the most recent submissions, all we have to do then is reference the read action that we just saw earlier, and we get back all the items that are in that table for our application. And it is this pattern of using SDK to essentially access Azure Mobile Services tables and then act on the tables using the scripting that really greatly simplifies the process of writing modern applications using mobile services. And finally, a variation of storing data in Azure is dealing with blob. In this case, the pattern is again very similar, some work being done on the device, and then configuration and scripting done in Azure Mobile Services. And Azure Mobile Services does all the heavy lifting of identifying where to store the blob and returning back the URL that the client then needs to work with to directly post the media using HTTP. And on the client, we're on a data service class that wraps up calls to a particular set of tables. And all we want to do is get back the URL that Azure Services will provide us in order for us to be able to store that blob. We specify the table, photo submissions blob, and then we run the insert action on it in order to get back the blob URL. On the Azure side of things, we can see that if we go to the photo submissions blob table and specifically bring up the operation for insert, we will have scripting that provides that connectivity into Azure Blob Storage. And we have some account credentials that we configure, and through the Azure Mobile Services, all that plumbing, all that infrastructure work to go in and create and connect to Blob Storage is handled for us, and we get back the URL that we pass back to our client app. And with this URL, all we have to do then is take it back to the client and run an HTTP put method to take the binary, and using the URL, store that with all the credentials that Azure Mobile Services returned back to us. And that is it for part 1 of this video. In part 2, we'll take a look at Azure Websites as a platform for our admin web portal, how we integrate it with mobile services custom API functionality, as well as scheduling features for scripting with third-party add-ons. For more info on Windows Azure, visit windowsazure.com. Thanks for watching.